Good morning, students. Today we are going to see some numericals on transport number. Before solving the numerical, first we have to see all the formula related with transport number. So formula list for the calculation of transport number. So n is equal to 1 divided by 1 plus r, where n is transport number of anion. Therefore, transport number of cation is given by 1 minus n. For Hitrov's method, transport number of cation is equal to fall in concentration of cation in anodic compartment divided by total fall in concentration in both compartments. Third formula for transport number is coming from moving boundary method. That is T plus transport number of cation is equal to L multiplied by A multiplied by C multiplied by Z divided by W. Also, L multiplied by A multiplied by C multiplied by F divided by I multiplied by small t. So, this two formula is coming from Hitrov's method. This two formula coming from your moving boundary method. This formula is coming from Hitrov's method, and this formula is used for the calculation of transport number. So now we are going to see the numerical based on transport number. The speed of ratio of Ag plus and NO3 minus ions is 0.88. So speed ratio, that is value of R, is given. Calculate the transport number of these ions, and we have to calculate transport number of Ag plus and NO3 minus ion. Since value of speed ratio is given, we have formula, that is n is equal to 1 divided by 1 plus r, where n is transport number of anion. So in this case anion is NO3 minus. So transport number of NO3 minus, n is equal to 1 divided by 1 plus r. After solving this, we comes it with 0.53, and therefore transport number of cation, that is Ag plus, is equal to 1 minus a n, which is coming as 0.47. Generally, this type of numerical is asked for 2-mark question in examination. Now we are going to solve second numerical. In an experiment based on Hitrov's method, it is important, KCl solution was electrolyzed between platinum electrode. This condition is important because platinum electrode is not attackable. 0.0137 gram of chloride was lost from anode compartment, and 0.0857 gram of silver was deposited in silver colorimeter connected in a series. Determine transport number of K plus and Cl minus ions. So number of, just see, 0.0137 gram of chloride was lost. So first of all, number of gram of equivalent of Cl minus lost from anode compartment is equal to 0.0137 divided by atomic weight of chlorine. So it comes 35.5 is atomic weight of chlorine. Divide this quantity with that, we comes with we comes with 3.859 into 10 raised to the power 4 gram equivalent. Also, it is given that 0.0857 gram of silver was deposited in silver colorimeter. So, total number of silver gram equivalent deposited in a colorimeter is equal to 0.0857. Since silver colorimeter is used, that's why divide this quantity with 108, that is atomic weight of silver. So it comes as 7.935 10 raised to the power minus 4 gram equivalent. Now, transport number of cation, we have formula: fall in concentration of cation in anodic compartment divided by total fall. So, transport number of cation K plus is equal to 3.859 multiplied by 10 raised to the power minus 4 divided by this quantity 7.935 10 raised to the power minus 4, that is 0.486. And transport number of anion, just minus this quantity with from 1, because we know that T plus T minus is equal to 1. So, transport number of cation is 0.486. So, put that value here. So, it simply means that we have minus this value from 1. So, transports, in this case, transport number of chlorine is 0.514. Now, just see, in an experiment of electrolysis of copper sulfate between copper electrode, it is important. Electrodes are not a platinum. Therefore, these electrodes are attackable. The total mass of copper deposited at cathode was 0.153 multiplied by 10 raised to the power minus 3 kg. The masses of copper per unit volume of the anode liquid before and after electrolysis were 0.79 multiplied by 10 raised to the power minus 3 kg and 0.91 into 10 raised to the power minus 3 kg respectively. Calculate transport number of copper 2 plus and sulfate 2 minus. So, mass of copper per unit volume before electrolysis, which is given 0.79 multiplied by 10 raised to the power minus 3 kg. Mass of copper per unit volume after electrolysis is also given, that is 0.91 10 raised to the power minus 3 kg respectively. So, in this case, we see clear cut see that concentration or there is increase in amount of copper after electrolysis. So, increase in weight of copper, so let it be Y, just minus this quantity from this, it comes as 0.12 10 raised to the power minus 3 kg. So, total increase in a number of CO2 plus would have migrated. So, total increase of number of copper 2 plus would have migrated, that is equal to 0.12 153 10 raised to the power minus 3 kg, which is given. So transport number of copper 2 plus is equal to x minus y divided by x. So just here x is 0.153 10 raised to the power minus 3 and y which we already calculated. So after solving this, transport number for copper 2 plus is 0.215. Subtract this 0.215 from 1, we got transport number of anion, that is sulfate. So it comes at 0.785. In a moving boundary method, using a tube with a cross-sectional area 1.24 cm square, 0.1 normal HCl was used to determine transport number of H plus and Cl minus ions. The boundary moved through a distance of 7.5 cm. The amount of current was determined by recording the weight of Ag deposited in silver voltmeter in series, which was 0.1209 gram. Calculate transport number of H plus and Cl minus. So length L is given, that is 7.5 centimeter. Convert this into meter. So it is equal to 0.075 meter. Cross sectional area is given in centimeter square. So A is equal to 1.24 centimeter square. Convert it into meter square by multiplying it with 10 raised to the power minus 4. Weight deposited, it is given. Weight of silver which is deposited is given, that is 0.1209 gram. So value of W is also given. Concentration of HCl is also given, that is 0.1 normal. So value of C is given, value of W is given, value of A is given, value of L is also given. Now just convert concentration term into gram equivalent per meter cube. So 0.1 normal, it means that 0.1 gram equivalent per dm cube. To convert this per dm cube into per meter cube, just multiply this quantity with 10 raised to the power minus 3. Now we have the formula P plus is equal to L multiplied by A multiplied by C multiplied by Z divided by W. So L multiplied by A multiplied by C multiplied by Z divided by W. We have value of L, value of A, value of C. Now what is Z? What is Z? It is atomic number of Ag, which is 108 divided by W. So it is equal to 0.129. So after solving this, transport number of H plus is 0.8308. So transport number of chlorine is 1 minus N. So 1 minus 0.8308 is equal to 0.1692. In a moving boundary experiment, using, it is important, 0.02 molar KCl, just see here, it is important, here is normal, here is molar. The boundary move by 38.7 millimeter in 20 minutes. So time is also given. length of boundary is also given. When a steady current of value of I is also given, 1.82 into 10 raised to the power minus 3 ampere was passed. The tube has bore of 4.146 millimeter. Calculate transport number of K plus and Cl minus. Now concentration is given, that is C is equal to 0.02 molar, that is equal to 0.02 gram equivalent per dm cube. Multiply this quantity with 10 raised to the power minus 3. So it is equal to 0.02 10 raised to the power minus 3 gram equivalent per meter cube. For KCl, molecular weight is equal to equivalent weight. Length is equal to 38.7 millimeter. That is equal to, multiply this quantity with 10 raised to the power minus 3 to convert this millimeter into meter. Bore of tube, that is diameter of tube, is given, that is 4.146 millimeter. Convert millimeter into meter by multiplying it with 10 raised to the power minus 3. So area of bore, because area of capillary have so inner side, the shape of capillary is like this. So it is circular in nature. So area is equal to pi r square. So r is equal to diameter divided by 2. R is radius. So after solving this, we comes with 13.49 10 raised to the power minus 6 meter square. We know that transport number K plus is equal to IACF divided by IT. Value of I is given, T is 20 minutes, that is 1200 second. Put all the values in the formula. So y comes with Tk plus is equal to 0.461. Therefore, subtract this quantity from 1, we got transport number of chlorine, that is 0.539. In our next class, we are going to see Kohlrausch law of independent migration of ions. Thank you very much.